Hi, back in February 2011, Agilent, as they were then called, released the 2000 to 3000 X series oscilloscopes, and they were absolutely groundbreaking scopes. The built-in waveform generator, 1 million waveform updates per second, etc. with that Megazoom 4 ASIC. Very impressive stuff at the time, absolutely industry leading. Nobody could touch them for a couple of years after that. And well, this turned out to be, the X series turned out to be the most popular and biggest selling oscilloscopes in Agilent and HP's history. And what have we got today? Well, another world exclusive. Out goes the Agilent 3000 series. You can still buy it, but they've replaced it with, ta-da! It looks exactly the same, but it's the 3000T. They've upgraded from the 3000A to the 3000T. Why is it called T? Because it's touchy. So about 2 years after they released the original 3000X series, they released the 4000X series, which I did a review on as well, and that'll be linked in down below if you haven't seen it. And that was a pretty impressive scope, but I was a bit underwhelmed by it at the time, even though it had the gorgeous big touch screen, all the touch screen technology, everything else, huge massive screen on it, very impressive scope, which is zone trigger capabilities, everything else. But I was a bit underwhelmed that they didn't have a new Megazoom 4 a new upgrade to the Megazoom 4 ASIC, which made the 3000 and 2000 series an absolute winner. So I was very excited to hear about this. So does this have a new Megazoom ASIC in it? No. Fortunately not, it doesn't. It's exactly the same Megazoom 4 ASIC with the same limited 4 meg memory that you got in your regular 3000 series. Sagan, there's no Megazoom 5 ASIC in it. Where's it gone?
Yeah, I don't know.
I think it must still be in the R&D labs at Keysight. What do you think?
Yeah.
Should they release it?
Yeah.
Yeah, I think it needs some more memory, don't you?
Yes.
Yeah, it's a bit of a shame, but it's still got lots of features, doesn't it?
Yeah.
And it's the same price. So that's got to be pretty good. Yeah, you want to check it out?
Yes.
All right. So just what have they changed from the original 3000 series? Well, hardly anything at all. Here's the new one. If you look at the differences, there's hardly anything. At first glance, very hard to pick between the two. The only difference is as far as the physical unit is concerned, and the look and feel of it, is that the new model has 2 extra buttons. There's a third button over here, which is, well, the touch button, and they've also squeezed in a little zone button there, but that's it. They're practically identical scopes. But they've had to actually do away with one button in terms of functionality. They've now moved the serial button, was up here, but now it's a dedicated FFT button. So the serial is moved down here, replacing what used to be the label button. They've added the touch button, which is was the help button on the original one, and now the help button is moved over here to this additional button. And as I said, we've got the zone triggering button just squeezed in up there, and it does kind of look like it has been squeezed in as well from the existing layout. But this is kind of makes sense, because that label button, probably one of the least used buttons on the scope. So really they've thought about, okay, which button can we take out there? Maybe they should have just added, kept the label button over here or something like that and added another one. But apart from those changes, everything else looks and works exactly the same, apart from the fact that, ta-da, we now have a touch screen. We can now move our waveforms up and down, and we can do all sorts of weird and wonderful stuff, which I'll no doubt show you. And although it's hard to really get a difference here, this new screen looks to be a little bit brighter than the previous one. And of course, it's a capacitive touch screen, and it does work really well. And as for the rear, absolutely identical. They've reused all the existing tooling for the cases. It still has the reasonably small but excellent little sort of built-in pouch, I guess you could call it, up there to carry your probes in. Once again, you can barely fit the 4 probes in there. It's a bit of an art to get them all packed in there. So yes, we've still got our trigger out, our external trigger in, our USB device and our USB host as well, and there's another USB host on the front, and the LAN VGA module is still optional extra. Bummer. And we'll see if there's any boot time differences. Here we go. And look at that, we have a winner at just over 40 seconds. The new one is substantially slower. It's going to take almost a minute to boot. Oh, no. Oh, come on. That's painful. Over a minute. No. What have you done, Keysight? You've gotten slower after you changed your name. Should have stayed as bloody Agilent. Still going. Oh, a minute 12. Look at that. But the reason for this is pretty obvious, because this new 3000T model actually uses the same code base as that newer 4000 one, hence because the 4000 already has all the touchscreen and everything else. So it is different firmware, still based on the original one, but they started using the code base from the 4000 inside this thing. Hence, it boots slower, it's got more bloat in there and whatever. And one very nice upgrade, you now get the 5 gig samples per second standard across all of the units, including from the 100 megahertz up to the 1 gig, sorry. And yes, the update rate is still the same because it uses the same MegaZoom 4 ASIC, so it's the 1 meg waveforms per second. Because before, you only got the 5 gig sample per second on that 1 gigahertz model before. The previous one, all of the 500 megahertz models and below, they were all 4 gig samples per second. So that's a nice little upgrade. And another big upgrade, but, well, they were pressured into doing it. You get the standard 4 meg memory now on all the models, even from 100 megahertz right up, because that's the maximum amount of memory in the MegaZoom 4 ASIC, and they've had to do that to compete. And that is still one of probably the only major limitation of this new scope, is that it still uses that MegaZoom 4 ASIC and is still limited to 4 meg memory. But to compensate for that, if you go into Acquire, yes, segmented memory is now standard across all the models as well. Once again, that was a paid option before, standard now, they were forced to do it. And just like the previous models, it does not display the amount of memory actually used. This touchscreen, I can't just go pokey poke. They do not actually display that. In fact, there's no way to actually choose how much memory you're going to use it. The scope always decides and uses the maximum amount of memory possible based on the current mode and the time base and everything else. So some people don't like that, but as a day-to-day use scope, I do really appreciate that, because you don't have to dick around with anything. It always gives you the maximum performance. And a new option not available previously is the frequency counter. It comes standard with a 5-digit one, just like here, but now, whoops, I automatically touch that. Now you can actually call that up, and you can actually have, ta-da, up to 8 digits, but that is an optional extra. You don't get that standard. It's going to take time. It's going to take time to calculate that, but you will eventually. Look at that, 8 digit, very nice. And to go along with that, and also to increase the performance of this thing, the previous model only had a standard time-based stability of 25 ppm, i.e., a pretty stock standard crystal oscillator in the thing, right? Just, Joe Bloggs one. But now they've increased that as standard to 1.6 ppm. Very, very nice. And it's also got a totalizer function as well, which once again, that's part of the optional upgrade package. It wasn't available in the previous model. And as an upgrade, you can now have up to 8 different measurements down here, whereas before you could only get 2. So now we can add as many as we want. Well, up to 8 anyway. There we go. Neat. And by the way, I've just had this run in overnight because I wanted to see what happened if I would try and trick up this totalizer, if it like rolled over or got something, got to some maximum internal figure. But look at this, 37.74 gigahits. So that's unbelievable. So yeah, it didn't fail at all. And that's how many times it's triggered and captured this waveform since last night. Unbelievable. And by the way, that totalizer there can count events, be they trigger events or any sort of capture event, up to 25 million times per second. Whoa, super quick. So the touchscreen interface is just like the 4000 series. We can just drag these dock, and we've got these various docks over here, and we can add various things, and then you can have them as solid dialogues or transparent. It's all very, very nice, and the various options come up for the different channels. You can change them all here. You can do all sorts of jazz, and then we've got our menu up here, which is designed to be based around a tablet so that you can actually fully control this thing remotely via a tablet. So you don't even ever need to touch the controls on this thing. If you don't, you can operate it remotely. It works the same way on the scope as it would on a remote PC or a tablet via Wi-Fi, for example. So it's beautiful and it's really well designed. They've actually put a lot of thought into this. They haven't just gone, oh, we'll just make this thing touch screen and that'll be right. And they've actually put some thought into the usability, how it's going to work across platforms and all that sort of stuff. So, you may not like touchscreen, but it's really darn handy. Like I can go up here, and if we're in move mode, for example, I can just drag waveforms up and down, and that's, that works really, really well. And then, of course, we can do stuff like drag our waveform across. You saw that it actually moved there, and we can drag it like that. Very, very nice. Or we can go up here and we can say, well, we want to zoom in to, that edge there, for example, and then you get all the various options. You can get the zone triggering, which we'll take a look at, or we can do the horizontal waveform zoom, or just the waveform zoom itself. Look at that. Fantastic. Works really well. You may not like touchscreen, but hey, this is implemented as good as you could possibly imagine. And if you're a screen poker like I am, and it's accidentally popping up and it's annoying the hell out of you, well, you just turn off the touchscreen with the button there, and nothing. You can't do anything at all. You can turn it back on. It takes a second or two to enable it back on, but hey, that's a really nice touch. Get it? And just nice little extra thing over the 3000 series, it actually highlights the current waveform that you've got operational here. So you can see they actually put a little highlighted box around that, and that really is quite neat. And that's not just for the touchscreen. That works if I press the channel 2 button over here or the channel 1 button. It's just nice. And it seems like they have much more confidence in this new model as well. They give you a 3-year standard calibration cycle instead of 2 years. Now, of course, the calibration cycle is only a recommendation. It's what your company implements. If your company says, well, we're going to calibrate our instruments every 6 months, well, that's what you do. But the manufacturer's recommended rating, they're confident that this thing will hold its calibration for 3 years, and you only need to get it calibrated every 3 years. So most companies will follow the manufacturer's recommendation on that. So that lowers your costs for recalibration, and they're quoted an MTBF, a mean time between failure, for this instrument as well, whereas they didn't quote it before on the 3000A series. They're now saying this will be reliable for greater than 250,000 hours. And that's a pretty bold claim, because that's 28.5 years reliability. Wow. I don't think they're offering a 28.5 year warranty though. but still, they've got a high confidence in the reliability of this thing. So, you know, they're going to be using quality parts in this thing, but geez, that's a long time. That's a big MTBF for a whole instrument. And one of the good things, of course, is that the built-in demos and things like that are really actually quite handy, not only just for reviewers like me to demonstrate the capability, but just to remind you how these sorts of things work. And there's lots of powerful little demos here that generate all these test signal waveforms that allow you to, you know, remind you how to set up trigger and things like that. Here's just one random one. It shows the auto ranging of the built-in DVM meter over here, and how it rescales it to, it tells you to maximize the dynamic range of the lowly 8-bit converter in this thing. But hey, that's nice, auto ranging DVM. And here's an example of the hardware-based mask testing, and this is actually generating real signals here. I can actually disconnect the scope probe on the front here, and it's just redoing this. So it's very nice. You can see how it's defined. Oops, I've completely, oh no, there we go. We've restarted. It's nice how I can just move that around. So you can set up these interactive demos, generating real test signals. In this case, they've got like this bad pulse here that the thing's capturing, and it's capturing this hardware in the real time. This is, of course, the advantage of the MegaZoom 4 ASIC I've showed in previous videos, but number of tests, look, it's 9 million. I've had it running for like less than a minute, and it's already done, you know, 10 million tests because of the million waveform updates per second, fastest speed possible. It's not always 1 million waveform updates per second, depends on the horizontal time-based range, but yeah, it's just super quick. Everything's done in hardware. This mask testing, serial decoding, everything else, still one of the standout advantages of the Agilent scope architecture, the MegaZoom 4 ASIC. Everything's done in hardware. None of this software rubbish. Doesn't slow down the machine at all. Brilliant. And same thing with eye diagram mask testing. Look at that. That's just, oh, it's just beautiful. And that's generating real signals out of the scope, and you can play around with it to your heart's content. Ah, oh, terrific stuff. Really, I'm changing the horizontal time base there. And the next demo just shows you the new high digit counter there. There we go. It automatically does it. And by the way, yes, we do have pop-up keyboards now, and yes, it does support USB keyboard and mouse as well on the USB if you want to, you know, interact with the machine that way. So there you go. It's just showing that it's a slightly lower frequency, and we saw that before as well coming out of the ARB-Gen. And there we go, that's the totalizer function. Accurately totals the number of input edges and counts both edges and trigger condition on qualified events. This example totalizes the number of runt signal inputs to the scope, so you can count the number of runt pulses, not the number of main pulses. Brilliant, super powerful. Now, of course, with the advent of the Tektronix MDO 3000 with its fantastic built-in FFT spectrum analyzer, well, Agilent have had to kind of sort of compete with that, and they can't really because the Tektronix has some, you know, real hardware and RF front end to do that sort of thing. But hey, you know, they're having a token attempt by replacing the serial button. They've moved it, and they've now put a dedicated FFT button there so you can switch that on. But we're going to have a look at the math mode first, and also an advantage of the new 3000T is that you can have the FFT mode and a math function on at the same time, whereas with the older model you had to choose between FFT or math. You couldn't have both at the same time. Now you can. So here you go, this example is just generating a basic waveform, and we're getting the harmonics there. This is the math function of that, and of course you've got measurement capability here as well. And further demos, I've done a video on this showing the integration capability, but you can cycle through. This is the absolute value. These are some of the math functions that are built in, and it's terrific. You can actually learn a lot by just playing around with this stuff. It's fantastic. Measurement trend of an FM burst. There you go. Okay, so I'm going to try out this zone triggering function, and this is very powerful. Instead of setting your trigger up more traditionally, we can go in here and we can select that, and we can go, we want to trigger on that right there, and we can must intersect. We can choose that it must intersect that box there, and it must, or it must not intersect, or whatever. So we can choose that, and bingo, zone triggering has come on, and we're going to trigger within that zone there. Look at that. Fantastic. I love that. That is beautiful. So not only zone triggering on runt pulses, we've got regular runt pulse triggering, but here we go. We can edge speed violation triggering and all sorts of fantastic stuff. There we go. It's showing you how to do that. And that's just so powerful to learn how to use this thing. It shows you step by step which menus to call up, where to move the, and what to select to set up a edge violation triggering, for example. It's just brilliant. And here we go. It's now set up the zone triggering. There we go, which I just did manually before, but now it's giving you a demo for that zone triggering. Very, very powerful, this zone triggering capability. I'm not sure whether it's available on other scopes. It might be called something else, but or it might be completely unique. But it really is quite powerful, especially when you combine it with the touchscreen and you can just draw around things. It's brilliant. And you can also trigger on qualified conditions as well, like A then B, for example, so you can set up sequential things to trigger like that in hardware. But they've done more than just whack an FFT button on the front. There's a lot more advanced capability in here now. Look, for example, this the white waveform up here, which actually looks blue on my screen, but anyway, on my camcorder screen, but it's white here, is the FFT function. So there we go. I can highlight that FFT function up there, and at the same time we can do a traditional FFT math function on, in this case it's the same signal, but it doesn't have to be. It can be on an entirely different channel. So I can now switch to math, and then I can choose which channel I want that from. So it really is quite powerful. And it's got, if we go to the FFT here, it's got gated FFT as well, which allows us to get the FFT function of a particular zoomed in part of the waveform. And this allows us to, you can even integrate this and correlate it with all the mixed signal stuff. So the analog signal and the digital signals as well. So if you've got a mixed signal design, it's getting there towards what you can do with the Tektronix MDO 4000, for example, with its time correlation between channels. But of course, the Tektronix MDO 3000 can't do that time correlation. It's either FFT or bust spectrum analyzer or bust. It can't time correlate like the MDO 4000 can. But this 3000T can actually time correlate between your digital channels, your analog, and your FFT spectrum as well. And because it's doing it all in the hardware, it's not necessarily slow. It's not going to slow this puppy down. Very nice. And I also got a debugging glitch example in here, so we can have a look at this. So we can have a look at find a coupling signal that catches the glitch. So let's have a look at that. And it tells you, of course, the million waveform updates per second. You can see the little runt pulses in there. It shows you how that you can actually trigger on these things. Here we go. You just take it. I could do it manually, of course, but it's going to do it for me. You draw the box around there, use the zone triggering, bang, and then you can get in there and identify that runt pulse. Very, very nice. And I can show you this time correlation. Here we go. In this example, they're going to use the gated FFT to correlate the time domain analog signal with frequency shift keying modulated with the digital signal, which is an I2C clock. And where they're going to do the I2C serial decoding as well, all in hardware in real time. And they're going to time correlate that to the frequency domain spectrum FFT. So let's give it a whirl and have a look. So this it's triggered on the I2C bus at the right frame, so all that's done in hardware in real time. And here we go. It's going to show us how we can go in and we can search for the frequency peaks. We can get that. We can set it up in the peaks in the dock over here. Very, very nice. And then we can start some time correlation. So yeah, this is damn impressive. And then we can use the navigate buttons to go through and find, and there's our I2C digital stuff, and we can time correlate and find that frequency peak. Very impressive. Once again, this is actually generating real hardware signals down here that you can manually play around with and probe yourself. So it's incredibly impressive what it's able to do on this base level scope. So yeah, it doesn't have a real, in quote marks, spectrum analyzer in the thing. It's still using the the basic ADC and doing the math and doing it all in hardware, of course, in the ASIC. But it is still very, very impressive capability how it can do time correlation between all your mixed signal stuff while doing hardware serial decoding and everything else. Yeah, it's thoroughly impressive. And we can also have a look at some of the intelligent cursor features. And in this case, we've got a clock signal, but it's got some noise superimposed in that. So we want to get an FFT of that. And it'll show you how you can actually go up there and do that. Switch it on, and we should get our... And then we'll turn on our math function and get our FFT. And then we can go in here and we can have a look and get our... Use our cursor, drag it over, and bang, intelligent cursor allows you to track the waveform math, and there we go. We can, and as I showed on the 3000T, you also got all these training signals built in, which, look, we've got all serial digital stuff, and then we've got all sorts of, infrequent clock with infrequent glitches, all sorts of stuff, and it will generate the hardware real time. Now on the 3000, this was available as an optional extra. I'm not sure if this is built into this one or whether or not it's only available on education models or something like that, but these training signals are fantastic. Because you can't always remember how to trigger on some, obscure thing and set up the scope. If you haven't done it before, you did it 5 years ago or something, and you just forget how to do it. This allows you to generate a similar signal to the problem you're getting, and then allows you to actually set up the scope and actually play around with it before and learn how to do that and trigger before you go probe your real signal. And of course, all the built-in serial decoding, which is optional extra, is all the same as what you got on the traditional 3000, all the mixed signal stuff. So there we go. It's just decoding real digital data here. Oops, got to stop poking at the screen. I'll hit my touch button to turn it off. There we go. And yeah, all that stuff all that goodness is still there. Once again, all that serial decoding, all done in hardware, but you've got to pay extra, but maybe they might bundle it in with deals and things like that. Ask. And there's an example of serial decoding the I2C bus. So that's pretty powerful. And it's got the event table up the top, everything else, all done real time in hardware. So yeah, the fastest possible signal you can imagine, I2C or SPI or any other serial bus, this thing will decode it all in the hardware. Your scope doesn't slow down at all. And of course, in the marketing blurb, they, go on about this. You get no slowdown with the logic channels, the protocol decoding, the math functions, the measurement, the vectors, or the sine X on X interpolation. This is all done in the ASIC hardware, and yep, I can vouch for it. And of course, they see the Tektronix MDO3000 as a real threat, so they provide comparison tables for the waveform update rate, for example, at 10 nanoseconds per division. I haven't confirmed these, but I'm going to take Agilent's word for it. I'm pretty sure it's correct, because the MDO3000 really does slow down a lot. As I've mentioned in previous videos, if you've got nothing turned on, it's a pretty fast scope, the MDO3000, but at the same 10 nanosecond per division time base, of course, you get over 1 million waveform updates per second, but you turn on the digital channels, for example, on the MDO3000, and it just dies, that update rate. It's terrible. If you turn FFT or anything else on and serial decoding, everything else, it's because they don't have the ASIC hardware to do it on the Tektronix MDO3000. So this is a really rip-snorting fast scope. Unfortunately, there's no new ASIC in here, but it's amazing how it's held up, this MegaZoom 4 ASIC, over this time period. It's just, it's still the fastest thing on the market. And by the way, all the advanced math functions that were optional on the 3000A are standard now on the 3000T, and so they'd want to be, for the price these days. They've got a competition in the industry. They've got to bundle it together. So, differential, integrals, FFTs, absolute values, all sorts of things we looked at in previous videos, digital high and low pass filtering and averages and smoothing and all sorts of advanced math stuff, all standard. brilliant. But all your serial decoding options, they're all still optional, I'm afraid. So yeah, if you want your I2C and your SPI and everything else, your CAN bus, then you've got to pay for it. But as I said, they might be able to, you might get this as bundled in or something like that in the future perhaps. And you now get the 500 megahertz passive probes standard across all the models. So even if you buy the 100 megahertz version scope, you get the 500 meg probes. Awesome. That means A, your probe's not introducing any issues on your signals, and B, you can upgrade that bandwidth at any time. Of course, you can't get like a 1 gig passive probe, so you could go buy the 1 gigahertz option on this, but 1 gig passive probes basically don't exist. So yeah, you've got to use an active probe or roll your own solution there. But yeah, great to get the 500 meg probes. But woohoo, look at this. If you buy the mixed signal option, they've got these brand spanking new digital probes. These are the N2756A. Now, of course, the same pinout and 0.1 inch header interface they've always had, but these look like redesigned. So these look very, very funky indeed. I love these things. Look at them. Fantastic. So they've got new probe ends on them and everything. So yeah, entirely different. Agilent have had the same digital probes across a lot of their models for, oh man, like 15 years or something now, and they've finally got the new ones. I'm not sure what the if there's any performance differences or whether or not they just physically look different and a bit sexier, but yeah, that's nice. And the old 3000A drew around about 67 odd watts with a power factor of 0.91. And the new 3000T takes 67 watts with a power factor of 0.86. Not much in it, but it's still got the ridiculous planet-destroying 6.5 watts standby. Jeez, you could fly to Jupiter and back on 6.5 watts. It's ridiculous. God, fix that, please. That's awful. And yes, the function generator is still the same as before, the arbitrary function gen. It's only one channel and it is optional, but the touchscreen interface makes the arbitrary waveform editor, for example, much more usable. It's just much simpler to use than, it's a similar appearance to what you got on the A series, but yeah, that touchscreen just adds quite a lot of value in quite a few places on this scope. It's really handy. Now here's an interesting difference between the Keysight 3000 and the Tektronix MDO 3000 low-level signals. We're on 2 millivolts per division here, 50 ohm input impedance. We're viewing a 100 meg signal here, and you can see the waveform is quite fuzzy. I've done a video explaining why this is the case, because it's much higher bandwidth, much higher sample rate, so you're going to get a noisy signal. We can clean that up with high res mode and all the rest of it, but let's not get into that, right? There's our average in and there's our high res mode. So no problems at 100 megahertz, and the tech will measure just the same. And there's the Tektronix MDO 3000. It's just fine, hunky-dory, once again at that 2 millivolts per, well, 20 millivolts per division. I haven't set the times 10 probe factor on that, but it's 2 millivolts per division. Our signal's just the same. Doesn't look as fuzzy because this is a slower scope. It doesn't update as fast. Done a whole video on that. Anyway, that's fine at 100 megahertz. Look what happens when we wind up the wick. So here we go. We're going to wind up the wick. There's our frequency there, okay? And look at this. Our amplitude's starting to drop, and that is not my signal generator. This is my good Marconi one. No, our signal is dropping. It's dropping. It's because the MDO 3000 has limited bandwidth at the lower volts per division settings. So that is a 1 gig signal, and there's nothing there. It's a 1 gig bandwidth, but there it is. But you don't get it because at the low volts per division settings. But on the Agilent one, No problems whatsoever. That's our 1 gig signal, and yep, it's all hunky-dory. You get the full 1 gig bandwidth right down to 1 millivolt per division. And there you go. They claim it's 150 meg bandwidth on the MDO 3000 and at 1 millivolts and 350 at 2 millivolts and 5 millivolts. And we'll get in around about that figure. We sort of confirmed about that figure, but we got the full bandwidth on our 1 millivolt on our Keysight one. So, and they claim lower noise as well. I'm not going to go in there and measure it, but they do claim, I presume that's RMS noise. There we go, at 1 meg point memory. So you can go in there and verify that. So basically, it's still the same 3000 series scope you used to, but it's got a fantastic new touchscreen and it seems a bit brighter. So it's just all better, and they've implemented, as I said, that touchscreen really quite well. I'm impressed with that. And if you don't like it, hey, don't use it. Just switch it off, dead easy. They've got things that have flowed down from the 4000 series, like the zone triggering and all the event tables. And the new FFT actually is more than just a button. It does provide some additional functionality with FFT and math at the same time, and all sorts of stuff, and gated measurement and gated cursors as well, which I haven't looked at. So yeah, it's a really nice little upgrade, and you get the 5 gig samplers per second standard across all. So ripper. Shame it doesn't have more memory though. So there you have it. There's the new Keysight, not Agilent anymore, Keysight 3000T. It is effectively a replacement for the 3000A. You can still buy the 3000A, but it'll only be available for select markets. This is the same price. It's designed to be a replacement, so you're mad if you bought the 3000A now. You go out and buy the 3000T. So if you're sitting on the fence before with the 3000A, then this one might send you over the edge, because can't fault it. The touchscreen interface, really nice. They've brought down all that functionality from, well, most of the functionality from the 4000 series. Unfortunately, still, well, they have included a lot of stuff standard that was optional before, but, you know, being tight ass, like the 8-digit frequency counter is optional and all sorts of stuff like that. And, well, go through the list, shall we? It's extensive. So yes, I do have a list. Who's been naughty? Well, Keysight have, because everything's still optional, even though they did generously include some things for free. Like I said, the serial decoding stuff, that's still optional. The waveform generator, waveform gen, mask limit testing, that awesome hardware-based mask limit, still optional. The MSO, of course, you can buy just the standard version and then buy the MSO later, and they'll ship you the probes. The power analysis stuff I've probably done in a previous video. That 8-digit counter, complete tight ass there. The education and training kit, that should just come in every scope. Put the damn thing in there. Unbelievable. Yeah, everything's, you know, there's quite a lot of optional extras. Now, just like the 3000A series, you have to choose your bandwidth carefully. If you buy the 100 megahertz model, you can only software upgrade that to 200 megahertz. The 350 meg to 1 gig are different models, but unlike the 3000A, you can actually choose to upgrade it with no additional cost at the service center, I believe. Anyway, if you have to send it back to get a motherboard replaced for the extra bandwidth front end, then they provide much more flexibility in terms you can jump from 100 megahertz straight to 1 gig, or you can do any sort of combination of those. So it's a bit better in that regard. And no doubt they'll start bundling things again to compete, you know, like they had an offer a while back for free ARB gen on the thing and all sorts of stuff. So no doubt they'll have those, and well, they've got to compete these days. The market is pretty tight. They don't have it all to themselves these days. And the only really thing that is a limitation on this thing is still the 4 meg memory, and they know it. Bet your bottom dollar they know it, and they're probably working on a new ASIC. But you still get leading performance in terms of just hardware update rate. This scope still cannot be beat even 4 years later. Nobody can touch it, and it's just as good, and that's the price you pay. So overall, while it's a quite nice upgrade, it's pretty underwhelming, I must say. You know, yeah, touch capability is great, and they've added a few extra things, but it's basically a 3000A with touch, and well, zone triggering's pretty darn good, but Yeah, not a huge amount extra, but hey, it's the same price. It allows them to milk the existing architecture for a bit while longer, stay competitive, and they're still pretty darn competitive. The only thing is that 4 meg memory, but that's it. Apart from that, still one of the fastest scopes on the market in terms of update speed and response time, and very, very usable. Brilliant. Relatively small memory at 4 meg. Even, $300-400 scopes have double or triple that amount of memory these days. But hey, you get that super performance update, and with the segmented memory it does some smart things anyway, so deep memory is not as important, but still it's one of the fundamental performance requirements of a scope. So that's the only thing I can really fault about this thing. It was an awesome scope before, and it's just as damn well good, even better now. So there you go. That's the new Keysight. Probably said Agilent a few times in there. 3000T for touch bottle. Awesome. I like it. It's brilliant. It's only comes down to a matter of, a value for money. Does it suit your requirements for value for money, as always? So anyway, I think it's an absolutely brilliant scope, and they're just milking the cash cow a bit more on their Mega Zoom 4 ASIC, just trying to, improve things. So not the giant leap we saw before, just a few little incremental improvements in here, but very, very nice, and it still smells good. Beautiful scope, the 3000 series. Awesome. So, hope you enjoyed that look at 3000T. If you want to discuss it, jump to the EEV blog forum down below. That's the best place to do it. And if you like my product reviews, please give it a big thumbs up. Catch you next time. Got to send it back. Bummer. Still happy with my 3000A.